Welcome Year 10 to exercise 6b. Today we're going to be discussing congruent triangles. Now we need to know what the word congruent means to start with. So first of all we need to be aware that the fact that congruent triangles just mean that we have identical triangles. They are exactly the same triangles. They've got the same size and the same shape, which means that you're going to have, in each triangle, you're going to have matching or corresponding sides which match up with each other, and the angles will also match up with each other. They'll be the same angles. Now, when we're talking about congruence in maths, we use what's a little bit like an equal sign, but there's three lines, and that means its shapes are congruent or exactly the same as each other. And when we talk about parallel lines, we have two vertical lines, and that means two lines are parallel to each other. If we're talking about two lines that are 90 degrees to each other, they're called perpendicular lines, and there's our symbol there for perpendicular lines. So there's a little bit of background for shapes and understanding. Just remember this, and these aren't drawn to scale. I could have a triangle that looks like that, and I could have that same triangle flipped and rotated, and it might come out looking like this. And they could be the exact same triangle because they both have a right angle, they both have an angle that might be those two might be the same, and all the sides match up. So you end up with triangles that are exactly the same, but they can be flipped and rotated and moved around a bit, but they're still the same shapes. Righto, before we actually do any examples, I want to just have a look at two triangles that I've put here, and I said that they are congruent. Now, we've put a whole lot of markers in them. These triangles are not drawn the same. They've been rotated or flipped or moved around a bit. Let's have a look at them. If you look at each triangle, I can see on the triangles that they've got that little single dash mark. Should probably go for the pointer rather than the pen. So I can see that little single dash. That means those sides are equal length. So I can say that the side AB and the side QR are equal. They are matching sides or corresponding sides. If I look at the sides that have three little markers on them, they're equal to each other. So we've got this side here going from B to C, or you could say CB, it doesn't matter. And this side here, P to R or RP, they're equal to each other. Those two sides match with each other or correspond with each other. And our third side that I haven't looked at yet, the side with double dashes, they're equal to each other. So AC and PQ match up with each other. They are matching sides or corresponding sides. Similarly for the angles. If I look next to angle A and angle Q on each of the two triangles, they both have a little circle, which means those angles are the same. So those angles match up with each other or correspond with each other. We can also look at the angles that are marked by a little square. We find that near the B and near the R. So I'm going to say angle B and angle R are the same because they both have a square. So they match or correspond with each other. And similarly, angle C and angle P have a little cross, so they match or correspond with each other. And because we have all the three sides matching and all the three angles matching, we can say those two triangles are congruent. The triangle ABC is congruent to triangle PQR. Now, when we're testing for congruence, there are four different things that we can look for. And these are the four tests. What we can do is we can look at our triangles, and if we can see that the three sides are all the same length, then they are identical shapes because the three sides match up. And that's what this SSS means. It means all three triangles have matching sides that are all the same length, or corresponding sides that are all the same length. Alternatively, we could also have two sides that match up with each other, so the two single dashes match up, the two double dashes match up, and there's an angle between them that match up, which means if you've got two sides and the angle between them match up and they're all equal to each other, then these two triangles are identical. They are congruent. The third test that we could be looking for is if you've actually got two angles that match up, the two single dots and the two double dots, and you've got a side length that matches up. So if you've got two angles and one side length on your shape that matches up, that's another way to show two triangles are identical or congruent. And our last test is RHS. If there's a right angle in each triangle, and each triangle has H for hypotenuses that are the same, and they have another side, the S, one more side that's the same, then those two triangles are right-angled and they are also congruent. You need to use one of those four tests every time you're asked to show triangles are congruent. So let's try our first example. It says show the following pairs of triangles are congruent. Now before I actually try showing they're congruent, I'm going to look at the angles and notice that I've got a 96 and a 96, but the 41 and 43 don't match up. But because they're triangles, if you know two of the angles, you can always find the third angle because triangles always have three angles that add to 180 degrees. So I can actually figure out what the missing angles are, and I've written them in because 41 and 96, when it's taken from 180, gives me 43. Over here, 180 take 96, take 43 gives me 41. So if I add up those three angles and I add up those three angles in each of the two different triangles, they'll all now add up to 180 degrees. Now I probably should have shown the working for that, but I'm actually just wanting to show the method for why they're congruent. So I've now got my angles. Let's have a look at it. They're my four tests. Which one would I use? Well, obviously not the first one because I don't have three matching sides on each triangle. I don't have three side lengths that I know on each triangle that equal each other. The second test, do I have two sides on each triangle and an angle between them? No. Third test looks promising. It definitely can't be the last test because there's no right angle. So, do I know two angles that would match up with each other and one side? Yes, I do. So I'm going to be using this test here, the angle-angle side test. So the first thing I'm going to do is I'm going to say that they're going to be congruent. They're going to be identical by angle-angle side. And here's the reason why. If I look at my triangle ABC, that angle up there at A, when I compare it to triangle PQR, matches up with the angle at Q. So angle A and angle Q both match up. They're both 41 degrees. Angle C and angle R both match up. They're both 43 degrees. I could have also used angle B and angle P because I know all three angles. I only need to use two of them for this rule. So you choose any two of the three matching angles and that's fine. I need to also have, if I'm using this third rule, I've matched up two pairs of angles. I need the side that matches up. Well, I can see that there's a side AC that's 20 and a side QR that's 20. So AC equals QR, they're both 20 centimeters. So those two triangles are congruent using the angle-angle side technique. Remember, I didn't have to use the 41 and 43. I could have used 96 and 43 and matched them up, or I could have used 96 and 41 and matched those up. Doesn't matter as long as you're matching two pairs of angles with each other. Let's go to example 2. Now this question says, prove that triangle ABC is congruent to triangle DEF. Let's have a look at our triangles. There's my four tests. With my triangles, I have 1 dash, 1 dash, 2 dash, 2 dash. I've got two sides that match up, and I've got an angle between those two sides. So I'm going to go straight to this one. I've got two sides and an angle between them. So I'm going to be using this test here, the side angle side test. So, which sides match up? Well, if I look at the single dash, I've got an AB, which matches up with an EF. So I've gone AB equals EF. Now I don't know their lengths, but I know they're the same because of those dashes. So what I do is I write AB equals EF, and that's given When I say it's given by those little lines. It means that they're the same length. Let's go to another part of the test, the angle part. I can see the angle up here at B, I've got a cross. The angle at E, I've got a cross. So the angle at B and E are both the same. I don't know what they are, I just got crosses there, but I know they're the same, so that is given. It was given because they both had a cross there. And the last part of the test is B to C has a double dash, D to E has a double dash, so BC and DE are both the same length. And again, that's given because I've got the double dashes. I don't know what the lengths actually are, but I do know that they are equal. So I finish up by saying that triangle ABC is congruent to triangle DEF. That means those two triangles are identical with their shape by the rule side, angle, side. You must include that when you're proving congruence. You need to finish off with your statement to state what's congruent and the test that you used. Okay, so there's our two examples. Now it's time for you to try some questions and have a lot of fun while you're doing it, because congruent triangles are enjoyable. Let's just face that as a fact of life.